There's no need to get tenser. Relax with Flux Condenser. Subscribe, baby, subscribe.
Welcome to Part 2 of the McIntosh MC2105 Restoration Series. In Part 1, we learned about the history of McIntosh and some details about the MC2105 amplifier we'll be restoring. If you missed that episode, you may want to go back and check it out. In this video, we'll recap the power supply. Recapping simply means replacing the old capacitors. Often, recapping is seen as the be-all and end-all solution to fixing any vintage audio ailment, and as a consequence, capacitors are often replaced for no good reason. In the case of antique power supply electrolytic capacitors, though, it really is a no-brainer to just replace them. They're a common failure point and are usually responsible for the annoying hum you often hear in old equipment. To learn more about how power supply filter capacitors work, please see my Antique Radio Restoration series, particularly the video entitled Capacitors: What, Why, How. The power supply in our 2105 works like this. First, the 117 volts of AC supplied by the power cord feeds the auxiliary outlet on the back of the unit. It then passes through a 5 amp slow blow fuse and switches. From there, it feeds two thermistors, which provide a soft start. Thermistors are resistors which allow more current to flow after they've warmed up. These connect to the primary winding of the power transformer. There are 3 secondary windings. One supplies AC current to the lamps, and 2 others are rectified by diodes to supply DC voltage. This section provides a positive and negative 35 volts, which is used in both the input and output boards. And this section provides 80 and 90 volts positive, which is used for the output. To smooth the pulsing DC coming from the rectifier diodes, filter capacitors are necessary. As a lot of capacitance is required to pull this off, large electrolytic capacitors are used. But the problem with electrolytics is that they tend to break down over time, and some need to be replaced every couple decades or so. In our power supply, there are 6 electrolytics that we'll replace. On the schematic, C301 and C302 are shown here. In real life, they look like this. C303, A, B, C, and D are shown here on the schematic, and in real life, they're all contained in this single multi-capacitor can. Our replacement caps were supplied in this restoration kit I purchased from C-Tech on eBay. The kit also includes other replacement parts, which we'll discuss in upcoming videos in this series. Note, though, that the MC2105 amp sold for a 10-year period, and there are actually a few different versions of the amp, which each have somewhat different components. The MC2105 we're working on is an earlier version, and some of the parts in the kit were not the correct values. This is important to keep in mind, as there are also many different service manuals for the amp available online. Make sure you're using the correct one. Let's start replacing those filter caps. Okay, we've got the 2105 on the bench now, and first thing we're going to do is we're going to start with replacing the components in the power supply. And the first 2 big ones we're going to do are these 2 very large electrolytics. Okay, these are the replacements, and right now we're looking at the bottom of the chassis, and this is the 2 lugs on the electrolytic replacements, and the lug on the existing ones are here, and here, and here, and here. Okay, so we're looking down, and these guys are facing, the terminals are facing up like that. So what we're going to need to do is remove these screws and remove the electrolytic cans from the other side, and then slip these guys in their place and screw it down. Before we do that, these are very large electrolytics. These are 39,000 microfarad at 40 volts, and they could, hold a bit of a kick there even at 40 volts. So before we do any work on these power supply electrolytics, it's a good idea to just check them and make sure that they don't have any charge in them. This unit hasn't been turned on in a couple months, I believe, so they'd probably have drained off by now, but let's just double check. Okay, the way we do that is we get our meter out. Okay, we're going to put it on DC voltage. Okay, maybe you can see that here, and let's just check these terminals to see if there's any charge on there. It doesn't matter which way you go, positive or negative. I don't really even need to know which one's positive or negative, although I can tell by looking at it. But if you had it reversed, all you would see is a negative voltage as opposed to a positive one. Okay, so let's just check this first one here. Okay, and 0 volts. And now this guy, 0 volts. So those are safe to touch. Now we also have another electrolytic here, which has 1, 2, 3, 4 different capacitors inside of it. Let's just check that one now. The one side of this is always going to go to the chassis, so we'll just individually check each one. Just a very, very tiny voltage there. That's totally safe. This one also very tiny, very tiny, very tiny. Okay, so these electrolytics are obviously safe to work on, so let's proceed. Now I believe we can just start with this first one by unscrewing these terminals. And I believe these screws are the only things holding the capacitors in place, so that should just slip out. If not, we'll flip it over and take a look. But let's just see now if I lift this, if I can. Yeah, that just drops right out. Okay, so can you see that? How simple that was. No soldering required. And let's take a look. Let's compare the two. Same exact size. Yeah. Looks good. This one here on the new one, it did have a chip in it on the plastic cover. I wasn't thrilled about that, but not a big deal. So I think what we're going to do is we're going to remove both of these guys. And these are so well tied together, we're not going to get confused there as to where the wires go. We can clearly see these lugs, these 3 lugs are contained together, these 2 lugs are contained together, and these 1, 2, 3 wires are connected together, and this one, very easy, just drops in, just one lug connected to that resistor. Alright, lift this up, pull this one aside, and note that the inner wire here is the positive. Just mark that very quickly with the red. This is our positive. And this one you can see is beginning to have something going on here, some leakage of some sort compared to the other one. This one too. Definitely some substance coming through there. So these are, and we'll test these too, but these are leaking, physically leaking at this point. Whether they're leaking electrically as well, we don't know, but we would assume so based on the physical condition. Okay, let's flip it over and take a look. It's an extremely heavy amplifier due to the very large transformers and the fact that this is capable of 105 watts per channel. These speaker wires were added for an optional setup that McIntosh, that the original owner had used, and I will be removing these, but we'll just leave these in place for now. Okay, but yeah, good opportunity now to get in here. You can see all this debris in here and dust, so why don't we blow that out a little bit right now, get it nice and clean. Okay, I'm just going to start with this white. And all of these boards will be removed so that we can clean them and service them, particularly these ones in the middle here, which have capacitors we need to change. And these are also the boards where we want to desolder these pigtails here. It doesn't have to be perfect for now. I just want to clean out this area here before we put the new caps in. But the chrome is in excellent condition. I don't see any pitting at all. Okay, now that we've got the chrome cleaned up, let's just take a look and see if there's a better way that we can position this so that we don't see this little defect here on the capacitors that they provided me. The positive on both of these needs to be oriented so that the positive is here and here. and the negatives are going to be facing the front. So this will be a negative, and this will be a negative. Let's take a look at the one with the, where is it? This one with the defect here, and see if there's a better way to do it. This is the positive here, so that would need to go facing forward, either there or there. So it really doesn't, there's really not a good way to do it. Probably I'm going to do is use this one in the back, so that, well, at least it's in the back and it's kind of hidden, as opposed to being, well, actually the middle, I should say, because this is actually the front, and this is actually the back. So better there than here, where you'll see it. So I'll just put it there. Okay, great. Okay, let's start by slipping the capacitor that's going in the middle first, and we'll slip this in from underneath. And you recall again that this is going to be the positive, okay? And this is going to be the positive, and this terminal will be negative, and this terminal is negative as well. Now, something to note here to help you, there is a bit of a clue on the physical part of these capacitors, okay? Let me get the old ones here. And you'll see, notice that again, it had this sort of vent where the electrolytic solution is leaking through. In both of these, you can see that they're leaking there, here and here. Well, note that when these are oriented correctly, those vents line up with a hole here and a hole here. Now, our newer capacitors also have a similar vent hole, okay? And you can see there's one here and another here, okay? So these are our two new ones. And you can see that this is oriented to the right-hand side when the positive terminal is facing to you. And this is hard plastic here. This is a soft sort of rubber here that's designed to break or to allow leakage from these capacitors if they were to overheat or to physically leak over time. So we need to keep that in mind when we orient that, okay? So these vent holes, when positive is facing us, is to the right. So that's another clue that these are going to be oriented that way, okay, with negative, positive, negative, positive. So just be aware of that. So the first one we're going to install is, again, this one with the tear will go in the middle portion. So let's work on that now. I'm just going to slip that underneath. Let's zoom up. Now again, if you look, you can see there's that vent right there through our hole. Okay, and there's our negative terminal. And there is our positive terminal, okay? So there are different washers that go in between these terminals and the chassis. Okay, so look what I have here. I have a whole bunch of stuff here. Okay, we have some red washers. We have some black washers with the sort of concave insets. And we have some regular washers. And these are our screws that were used to hold the terminals in place that go into the capacitors. Okay, all this hardware was previously here. So it fell out, and I've collected it. And I'm going to show you now how to put this all back together. First thing to know is that the first washer that goes towards the chassis are these orange washers, okay? After that, you're going to have one of these black washers. If you're confused which side goes which way, you might be tempted to put it this way with the concave side sort of on the top here as we're looking down at the bottom of the chassis. Actually, they go this way, okay? So this concave area, if you're working on the back of the bottom of the chassis, flip that down, okay? And that's going to slip in underneath our terminals, okay? And I'm going to align that with the screw hole for the capacitor underneath, okay? And get that all sort of aligned by eye. Now, these ones also have a washer. And let's slide that into position. Tweezers are always helpful. Okay, just drop that in and I'm gonna try to just align that all. Just lift this out of the way for a second so we can really see that. A little bit tricky. Take your time, be patient. I'm saying that to myself, not just to you. Take your time, Chris, and be patient. because this stuff can get frustrating. For the top lug, the middle lug, and then carefully lower it down. Hold it in place with your screwdriver. Now you may need to lift the capacitor from below to just bring it up enough so that the bolt can catch that thread in the capacitor. Okay, so there we go. And just loosely for now, because we're going to do this this next terminal as well. So again, let's start with our orange washer, then a black. Again, concave side facing downward. One of our bolts. And let's see if I can't find that thread. Again, I'm going to lift from below, push it up, and did we get it? Yep. Looks like we got it. Okay, good. Tighten that one, tighten this one. These are pretty hard plastic, these washers, but there's a little bit of compression there, so you do want to be careful. Don't over tighten these. Just, you do want to have a good connection here because there's no solder. Remember, on this capacitor now between these lugs, I mean, if you wanted, you could elect to solder them. I'm not going to do that. I don't think it's necessary. But yeah, just tighten it enough just to make sure you have a good connection there on the terminals. And remember, this is the only thing that's holding those capacitors in place, so you don't want it to loosen up over time. Okay, let's move on to the next capacitor. We have the positive terminal and the negative again. And this is our negative and this is our positive. So we want the positive to be facing towards us if this is the back of the chassis, the back of the amplifier. Negative, positive. Let's slip that underneath. And again, also remember, we have our vent hole here, which should correspond to this hole here on the chassis. If you don't see these rubber vents here on these capacitors, you've installed it the wrong way. Right about there. Slip an orange washer underneath. Okay, now black. All right, right about there. This one does not have the additional metal washers, so we don't need that. We're just going to take our bolts. Maybe I'll drop that in with this pair of tweezers. Push down with my screwdriver. And again, I'm going to from below, I'm going to lift the large capacitor up a little bit so to help that bolt find that thread. Okay, there we go. Okay, just loosely for now. Again, we still have to do this terminal. Start with our orange washer first. Black. This one uses the metal washer. Take our bolt, slide it through the lug and the washers, and okay, go ahead and cinch that down. When you're doing this, really make sure that the capacitor on the other side is fully seated and fully against the chassis, and also that these washers are fully seated. They have a tendency to want to get jammed. You could be tightening these screw terminals and thinking you've got it, but you don't, because it's actually a little bit crooked. So really double check your work. On this one, I had to go back and unscrew this a little bit and push this up and jiggle this a little bit to really make sure it was seated correctly. Okay. If these connections aren't good, you can have, this is where the power all comes from, you're going to have intermittent power issues. There's going to be trouble. So, and I'll probably be working on this all week, so before I tidy everything up, I'm going to go back and I'm going to double check these threads to make sure that they haven't loosened up a bit. Let's just double check our work in comparison to the photo. We have the red the yellow green here on our negative terminal. Okay. We have our resistor connected between the negative and positive. Okay, we have our two red wires here. We have our one red wire there. Moving on down here, we have the two greens, the green and the resistor connected here. This one just has the solitary black cable. So everything looks good, everything looks cinched down. Great, we have the two large electrolytics now successfully installed. Okay, let's move on now to replacing this multi-section electrolytic. I've done a quick drawing here just to show the lay of the land here. We can see that on the semicircle terminal we have an 8200, 80 microfarad at 200 volts. This is the non-marked terminal, 50 microfarad at 150 volts. The square indicator marks the 80 microfarad 200 volt terminal, and the triangle marks the 150 terminal. And here's the replacement. You can see the voltages are a little bit different, but microfarads are the same. Got, let's see, semicircle is 80 to 100 on the new one. The replacement is 80 to 50, so they've upped the voltage a little bit. On the square, 80 to 50. Here, the voltage, it's the same, except the voltage has gone from 200 to 250 again. And the triangle, 150 to 250. This one, the voltage has increased quite a bit from 150 to 250. Not a problem. Going up a bit on the voltage is never a bad idea. It's rated to handle more voltage, so that's always a good thing. And on the non-marked one, we've got 50, 150, and now 50, 250. Okay. So on these multi-section electrolytics, you'll often see the symbols used to denote the different sections, because this actually contains 4 capacitors inside. So you'll see that the semicircle, square, and triangle is used quite a bit. Even though I've done the drawing, I'm going to actually additionally mark on the chassis the orientation of this so we don't get confused. I'm just going to put a little semicircle here. I'm going to put a triangle here and up, and I'll put a little square at the bottom here, and we'll erase that later. But even though I have the photos and the diagram, I just want to be on the safe side. So what we're going to do is we're going to use our desoldering iron to vacuum out the solder and remove these leads, and then we'll have to not only desolder these lugs here for the ground terminals, but twist them. Those are actually what's holding the electrolytic can in place. So once we do that, we'll be able to remove this and replace it with a new one. So I've got the desoldering iron all warmed up. I'll put it in camera here so you can see. We're using a Hakko FR301 today. All warmed up. Let's begin. I'm going to also put on our Hakko fume extractor. So you're going to hear that in the background. It's going to be a little loud. I like to use this when I'm desoldering or soldering. Here we go. Okay, there's one wire removed. Okay, we've got the 3 white blue wires removed. I'm just going to tie these together real quick with a tie, just to make sure those stay together. We've documented this so much it's not really necessary, but it's kind of a habit I've gotten into. Okay, and here on the diagram you can see we have actually I only listed 2 white blue wires. Let's draw another one. There are actually 3. Let's move on. Okay, slowly working these solid blue wires out. And I'm trying to preserve the wires as much as possible. I don't really want to snip these wires, so we're trying to reuse these connections. We don't want to cut these and have to shorten this and later on not have enough wire. Just taking our time and being very careful. There's no need to snip those wires. If you can see here, a little bit of solder dropping down. You want to make sure that you remove any of this solder that splatters when desoldering. A couple little solder balls here on the bottom. Another one. So before we power this up, after all the repairs have been made, before powering on, I'll blow this out lightly with the compressor, and we'll turn it upside down and shake it just to make sure that any little pieces of solder or metal flakes don't remain, because you don't want those floating around in there, obviously. As I work, I still try to remove excess solder as I move along. Okay, we still have this one last blue wire here. Let's add a little more heat. Let's see if we can't remove it. So once I heat it up and I've removed the solder, I'd like to keep jiggling the wire so it doesn't refuse itself. If you keep jiggling it, it won't refuse as the solder cools. So that's a kind of a good trick. Okay, there are our 3 solid blue wires. Okay, we have our solid blue wires removed and our blue-white wire removed. Let's move on. We have left the white-red wire and the solid red wire. Solid red wire removed. Just have to remove solder blob here on the red-white wire. There we go. Now you can see that these inner lugs are the actual terminals for the capacitor, whereas these outside ones, one here, one here, one here, and one here, these do provide grounds for the 4 capacitors inside, but they also serve as a mounting tabs to hold the capacitor in place. You can see again that they've been soldered. Well, they've been inserted, then twisted, and then soldered to hold them in place. Actually, the holding them in place is really just done by the twist. They've soldered it here just to make a good connection here between the outside of the electrolytic and the chassis. What I'm going to do is I'm going to twist these back into position to straighten them out so that we can slide it out, and we'll also twist this one and see if that doesn't break the solder, and if it doesn't completely break the solder, we'll try to vacuum that off as well. There's one. It's a tight spot. So just try to straighten these lugs out as best as you can. If you get a particularly stubborn one, you can always try to snap these off as well, because we're not going to be reusing that electrolytic. We may need to do that on this one. This one's a little tricky here. Okay, now for the one with the solder. Let's give a little shake here and see if we can't loosen that. I think we're going to need to remove the solder on this one, and this one we may have to just break off altogether. Let me see if I can twist that one. Just going to keep bending this one until it loosens up. There. Okay, so we remove that. Let's use the desoldering iron to remove some of the solder. I'll break this one off too, just to make things a little easier on ourselves. And break this one too. Why not? Should come now. There we go. That's a tight fit. All right, there we go. Just managed to get that out. We have a Mallory made in USA. Okay, and we might test this later as well as the other electrolytics that we've replaced, just to see how bad they are. As you recall, we had the triangle here, the square on the bottom, and the semicircle over here to the right. Just have to bend some of these tabs of hair to get them to fit. Let's bend this one down. And this one. Okay, there we go. Okay, you can see it's a perfect fit. So the first thing we want to do before we do any soldering is we want to double check our alignment. Okay, and I can see the can here. I can see the semicircle. I can see the square. And over here, the triangle. Okay, and this is the unmarked one. So what we're going to do is we're going to pull this flush, and we're going to twist these lugs to hold the capacitor in position. Just make sure when you bend these in that they don't contact these actual terminals here, okay? These are a little tight, so I'm going to try to actually bend these. Usually I twist them more, but these I might try to just push out of the way a little bit. Like that, just to make sure there's no shorts there. I've never done it that way before, but I think for this it's probably a good idea. Okay, very securely in position, and again, these got these tabs out of the way, so we don't have to worry about any shorts. Let's look at our wiring diagram again. Why don't we get these? These are pretty easy to do. The red and the red-white, there's just the one, and the top one we have good access to. I'm going to suggest we start with these three solid blue wires here on the triangle, okay? Let's use our tweezers. Just sort of wrap it around the way McIntosh had it. There's one. There's two. Okay, we have our blue wires in place. Let's solder those now. Let's just put a little dab of flux on there. Clean up those old wires. And make sure the solder flows well. Okay, looks good. Let's move on, and why don't we do our bottom one now, and we'll just double check to confirm that, yes, that is our red and white striped wire. Goes to the square on the bottom. Let's just tin the tip of the wire a little bit so that the strands don't fall apart, just to strengthen the wire a little bit. And because once it's soldered with the tin, it's tough to bend into shape. I'm just going to kind of make a little hook on this first, so we have the shape we want before we put it into the lug. There we go. All right, let's solder that guy in. So interesting copper terminals on these capacitors. Never seen that before. Good, got a nice connection there. Forgot to turn on the fume extractor. My lungs are feeling it. Okay, looks like we've just now got the blue-white striped wires. And when we're done with all the soldering, I'll go through everything and we'll use some flux remover to clean up these connections. Let's just double check looking at our drawing. 3 white blue wires. 1, 2, 3. 1, 2, 3 solid blue wires. 1, 2, 3. And white red wire. White red. And red red. Okay, that looks good, and that completes the installation of the multi-section can. Oh, one more thing. One thing we did not do is we have not soldered one of these lugs to the chassis, and that's going to be important. Okay, we need to have a good connection to the ground of the can, because that creates the ground connection for all 4 of these points. So it's very important that this be soldered here. This isn't quite good enough, so I'm glad I remembered that. And why don't we use, this is the lug that they had used to solder. Why don't we use the same lug? So we use lots of flux here. Okay, when you solder a big point like this, a big chunk of metal, which is, kind of heat sink not only by the chassis, but actually by the exterior of this can, you're going to need to use, I would recommend using a lot of flux and a lot of heat and a tip with a pretty good size head on it. And I think what I have on here now is just going to make it, but we'll probably have to use a pretty long dwell time to really heat that up. Let's see how it goes. Okay, so we've got a nice solid connection here, you can see, and I used a lot of flux on this, so we've got a lot of extra that we'll need to remove. You can see here I've kind of scraped off this blob. You don't want to be leaving this on there. So again, when we're done and ready to wrap this up, we'll go through and remove all the excess flux on our connections and clean up the board so they're nice and shiny. Great. That wraps up part 2 of the MC2105 restoration series. Stay tuned for part 3, where we'll restore the input board. To stay updated, subscribe and click the bell. And if you like this video, please give it a thumbs up. I'll see you soon.